Hi everyone, welcome back to the channel. I'm an aircraft engineer, and in this series we'll break down aircraft systems in a clear and practical way. From all the main systems, step by step, how they work and why they matter. So if you're a student, technician, or aviation enthusiast, please give this video a like, subscribe to the channel, and turn on the bell icon for notifications. Your support really helps the channel grow. Let's get started.
Have you ever looked out the window of a plane, like an Airbus A320, and wondered how it carries enough fuel to fly for hours? And what that fuel is really doing besides just making the engines roar? Well, today, we're going to peel back the skin of an A320 and take a deep dive into its incredibly smart and absolutely vital fuel system.
So get this, a typical A320 can hold around 24,000 liters of jet fuel. That is a massive amount. We're talking enough to easily get you clear across a continent.
But here's the thing, that fuel isn't just for thrust, it's doing so much more. So how does an airplane like this manage its lifeblood? The whole journey of that fuel, from the truck on the tarmac all the way to the engine, is just a marvel of engineering. Let's start right at the beginning, just getting the fuel onto the plane. All right, so the very first step is this highly controlled, super precise refueling process, and it's all managed by a pretty sophisticated system. This is where it all starts. Think of the fuel quantity indicating computer, or the FQIC is the brain of the fuel system. It's so smart it can automatically load the exact amount of fuel needed for a flight, down to the kilogram. But, there's always a backup. The ground crew can take over and do it all manually from a little panel right there under the wing. Okay, so the fuel is on board. Now what? Well, the aircraft has to solve some major engineering challenges to store all that liquid safely while it's cruising miles above the Earth. First off, the fuel isn't just sloshing around in one giant tub. No way! It's strategically split into 3 tanks, one in each wing and one in the center section. And here's a really cool detail. The plane is designed to always use the fuel from the center tank first. Why? Because as that weight in the middle disappears, it actually reduces the stress on the wings. It's a brilliant piece of design that helps extend the life of the whole airframe. Now picture this. The plane is climbing up to 35,000 feet. The air outside is getting super thin, right? The pressure is dropping like a rock. If the pressure inside the fuel tank stayed the same, that difference could literally damage the plane's structure. So how do they deal with that? Well, the answer is a really sophisticated venting system. You can basically think of it as the tank's lungs. It lets air move in and out to constantly equalize the pressure inside the tank with the air pressure outside. It's an absolutely crucial safety feature that protects the plane at every altitude. Okay, but what about when the plane is banking hard or climbing steeply? You've got thousands of liters of fuel moving around in there. You have to have a way to stop it from just pouring out of those vents, which would be, well, catastrophic. And this is where the design gets even smarter. There are these small surge tanks located way out at the very tips of the wings. They basically act as an overflow catch. So any fuel that gets pushed out into the vent system during a maneuver gets safely caught in these tanks, and then it just drains right back into the main tanks once the plane levels out. Pretty clever, right? So the fuel is stored safely. Check. Now for the most important part, getting it to those massive engines. But it's not as simple as just opening a tap. There's a very specific, very intelligent logic to how it all works. So, like we mentioned, the system is smart. It automatically empties that center tank first to take the load off the wing roots. It's only after that center tank is completely empty that the engines start sipping fuel from the wing tanks. It all happens automatically. But aviation is all about planning for what could go wrong. So let's play a what-if game. Each engine gets its fuel from pumps inside its own wing tank. But what if all the pumps on, say, the left side were to suddenly fail mid-flight? Well, without its pumps, the left engine is about to be starved of fuel. It would just shut down. This is where a critical layer of redundancy, a key safety system, comes into play. It's all about this, the cross-feed valve. By opening this one valve, the pilots can connect the 2 sides of the fuel system. This lets the working pumps on the right side push fuel across to feed not just the right engine, but the left engine too. It is such an elegant, simple solution to what could be a really disastrous problem.
But hold on, the fuel's job isn't done yet. It actually has this whole secret life, performing other really vital jobs for the aircraft that have nothing to do with thrust. So all that jet fuel sitting in the wings is cold, right? Well, the plane uses it as a coolant. It gets pumped through heat exchangers to cool down the engine oil and also the oil for the integrated drive generators. Those are the things that produce all the electricity for the plane. Oh, and it's also the power source for the APU, the little jet engine in the tail that gives the plane power when it's on the ground. Okay, so with all this automated, complex stuff happening in the background, how do the pilots keep track of it all? Well, for that, let's head up to the cockpit.
Remember the FQIC, the fuel brain? This is where it really reports for duty. It's constantly taking readings from a whole series of probes inside the tanks, crunching the numbers and feeding that information in real time right to the pilot's screens.
So the pilots get their main fuel info from a digital display system right in front of them called ECM. It gives them precise numbers. But what if the power went out? Well, there's this brilliantly simple backup: magnetic level indicators. They're literally just little float gauges under the wings that work with zero electricity. A true old-school reliable backup. And here's the most important part. Even though this system is designed to be almost completely automatic, the flight crew always has the final say. They have switches right on the overhead panel that give them direct, manual control over the fuel pumps, and, of course, that all-important cross-feed valve. There's this quote taken right from the aircraft's manual that just perfectly captures the whole philosophy here. It says it all. Build a smart, automated system, but always, always make sure a human has ultimate control when they need it.
So after seeing all this incredible automation, all these backups and redundancies, it all comes back to one crucial human element, doesn't it? Getting the fuel calculation right before you even leave the gate. It's a powerful reminder that even in our most advanced machines, the human touch, well, it remains the most critical component of all.
If you found this helpful, please click the subscribe button and hit the bell icon so you won't miss the next lesson. Thanks for watching, and I'll see you in the next video.